I'm Aparna Sharma, tutor for chemistry. Today we will be covering redox reaction. But before we enter into the subject, briefly I will run through how to access the revision notes and test in Playsix website. If you go to playsix.com and click on practice, here we will pick the that is NEET Premium, and NEET Premium has 4 test series, that is for physics, chemistry, biology, and full test. So under each subject we have n number of tests. And if we select chemistry, for each sub chapter we are having test assigned here, and each bubble is a test, and the R bubble is to assign a random test on the same chapter if we need any additional practice. Every test can be taken n number of times, and a blue bubble means a test that is not yet taken. Green bubble indicates that test is completed, but it can be retaken. There is no hard and fast rule that we need to take the test only once. And in today's class, let us talk about redox reaction. And if you click on revision notes, it opens in a new tab which will give you the precise understanding about each chapter. And today's session we are going to discuss about redox reaction. So if we say redox reaction, what is it? The reaction redox, the reaction in which oxidation and reduction both is going to occur simultaneously. So you can say, if we say chemical reaction, that is going to have change, that is strictly going to involve the motion of electrons, and we have forming and breaking of the chemical bond. So when we say reaction, the reaction can be of 2 different types, that is oxidation and reduction. So if we say the term oxidation, it was first used to mean the addition of oxygen to an element or compound, or the other case we can say it is also considered to be removal of hydrogen from a compound. So oxidation does not mean that it is only addition of oxygen to an element, but it also means that you will have removal of hydrogen from a compound. So when we say the redox, the reaction in which oxidation and reduction is going to take place simultaneously. And if we say oxidation, it's of course addition of oxygen, or we can say removal of hydrogen. But when we say reduction, reduction means vice versa of your oxidation, that is addition of hydrogen to an element or compound, or the other case we can say removal of oxygen from that compound. So when I say redox, that means oxidation and reduction should take place simultaneously, then we consider that as a redox reaction. And next important concept in that is to learn about oxidation number. So residual charge which is being present on the atom when the atom is in combined state, when the atom is in combined state with other atoms. So oxidation number of atoms, basically there are certain rules which we are supposed to know, that how the oxidation number can be calculated. So before we calculate the oxidation number, it is very important to know the rules. So the oxidation number of hydrogen is basically taken it to be +1, but whenever hydrogen forms a metal, the oxidation number of hydrogen becomes -1. And it is also important to note that the algebraic sum of your oxidation number of all the compounds in the atom, that is taken it to be 0. Algebraic sum, it will be taken to be 0. And second case is, if suppose we are having any charge If we have any charge, then it is taken as the charge of that particular ion. So oxidation number, first rule is for hydrogen. Second, we can say oxidation number of atom in elemental state, it is equal to 0. These are all the things we should remember. It is to be understanding. So when we say oxidation number of atoms in elemental state, so immediately we should understand that if any element is considered, the oxidation number automatically should be taken to be 0. And oxidation number of your metal, that is always positive, and for non-metal it is negative. And when we consider oxidation number of oxygen, oxygen shows an oxidation state of -2 in almost all the compound except when it is forming a peroxide or superoxide. Except when it is forming peroxide and superoxide, it takes the oxidation state to be -2. So when we are trying to derive or when we are trying to analyze the or your redox reaction based on the concept of oxidation number, it is also important that if oxidation involves increase in oxidation state, if it is involving increase in oxidation state, we say that it is undergoing oxidation. And if any element is having decrease in its oxidation state, that is between a reactant and a product. If we say in the side of reactant, and if you consider the same element in the product, if there is a change in the oxidation number, based on it also you can predict whether the given reaction has undergone oxidation or it has undergone reduction. So when we say that that is your reaction. So there are different types of redox reaction. There are different types of redox reaction. So first one, as your, we can say combination reaction. What are all the combination reaction? Immediately we say when two or more reactant react to form a single product. When two or more reactant react to form a single product, we say that it is a combination reaction. So it is 100% sure that when we say A is reacting with B, it will give us a product AB. So this we consider it as a single product. So we have to analyze that for the reaction to be redox, both the element should be in elemental form. So ultimately when it is in elemental form, the oxidation number will be 0 here, and when it is forming a compound as the product, it is 100% sure that there will be there will be either increase or decrease in the oxidation number. Hence you could conclude that it is a redox reaction. And the second part of redox reaction or second type of redox reaction is decomposition reaction. That is a type of reaction in which reactant breaks up into its constituents. Reactants breaks up into its constituents. So you can say vice versa of the combination reaction, where we are, so for example, we can say if I say H2O, H2O breaks up into your H2 plus O2. So we are saying that it is a decomposition in which the reactant breaks up into its constituents either by, we can use the concept of heating or passing current or in presence of light. So we say that as decomposition reaction. And then it comes as your displacement reaction. In any displacement reaction, the atom, ion, you can say in a compound, it is being replaced by the atom or ion of some other element or compound. So in a displacement reaction, for example, we can say it as CuSO4 when it is reacting with zinc. It will give us ZnSO4 plus Cu. So here displacement reaction fits here. Metal displacement as well as you are having non-metal displacement. So we could say that it is obvious that zinc has got, has displaced copper. So there is an 100% surety that some Cu will be having an oxidation number here, but here since it is in elemental form, it is 0. So it is important to note that the element which is undergoing oxidation, the element which is undergoing oxidation will act as a reducing agent. Vice versa, we can say oxidizing agent and reducing agent. So whichever is undergoing oxidation, it will act as a reducing agent. Whichever is undergoing reduction, it will act as an oxidizing agent. And the next reaction is a disproportionation reaction, in which you will have same element is going to be oxidized as well as reduced. The same element will be oxidized or reduced. So we could conclude that a reaction in which the same species is simultaneously being reduced and oxidized. It is being reduced and oxidized simultaneously. Hence, we can say that it is a disproportionation reaction. And neither reduction nor oxidation will occur alone. It is an important fact to note that neither reduction nor oxidation will occur alone. Both of them has to occur simultaneously, because since both these reactions must occur at same time, they are termed as redox reaction. So there are chances that question may be asked why it is considered to be, or why we need the term redox reaction. It is 100% that we should answer when both these reactions must occur at the same time, then only we can say that it is a redox reaction. So the reaction which is taking place in batteries, it is of course a redox reaction. The redox reaction, that is reaction taking place, are such that the electrons transferred can pass through some external circuit so that they will produce electric current. That is why there are many examples which we can consider it to be a redox reaction. Hence, it is important to know what is electrochemical cell. What is electrochemical cell? So it is a cell in which the chemical energy gets converted into electrical energy. The chemical energy gets converted into electrical energy. It is very important to note, and we can say that it is a spontaneous reaction. And in electrochemical cell, the reaction which takes place, we could consider that it is a spontaneous reaction, and the Gibbs free energy, of course we all know when it is spontaneous, the Gibbs free energy should be negative. And when we say as electrochemical cell, this cell is going to consist of two half cell. In one half, there is, you can say, zinc sulfate solution will be taken and zinc rod will be dipped in it. In another half cell, 1 molar aqueous solution of copper sulfate solution is taken with copper rod in dip. So there is a structure, or there is a construction which we could study in electrochemical cell. And when we say as electrode potential, what is electrode potential? And yes, in electrochemical cell, the important point to note is salt bridge. The important factor to note in electrochemical cell is salt bridge. That is, it is salt bridge is the one in which you can say that it will connect the circuit internally by connecting the solutions. And the best part is salt bridge is the one which is used to maintain the neutrality in any electrochemical cell. It is the best, the most important part, or the most important function of the salt bridge is it helps in maintaining the neutrality. And next we are having electrochemical cell, electrode potential. So when we say electrode potential, it is a potential difference set up between electrode and electrolyte of the same beaker. It is a electrode potential is the potential difference set up between electrode and electrolyte of same beaker, and we are having two different types of electrode potential. One is reduction potential and the other one is oxidation potential. So when we say reduction potential, it is nothing but the tendency of the solution to get reduced. Tendency of the solution to get reduced. And oxidation potential is tendency of electrode to getting reduced. Tendency of an electrode to get reduced. And another important factor which we should make a note in electrode potential is what are all the factors which will affect the electrode potential, or in other terms we can say electrode potential is depending on what are all the factors, or what are all the factors will affect the electrode potential. So it is very important to note that we should have the factors which is affecting your electrode Okay. Sorry for the inconvenience. So the reaction which we are saying, a bleach is a chemical that is being, a bleach is a chemical that can remove or lighten the color, usually via oxidation. So we are using bleach in our day-to-day life, and a bleach is the chemical that is being added to remove or lighten the color, usually via oxidation. And ordinary household bleach works by oxidizing substance that can stain fabrics, making them colorless, or it is easier to remove from the fabric. So this is a process, or this is a concept of redox reaction which we are using in our day-to-day life. And fluorine is the most electronegative element, and it is a factor to note that its oxidation number will always be 1. So the highest oxidation number of an element cannot exceed its group number, and the minimum oxidation number of an element is equal to its group number. So it is a hint to, or we can say that it is a trick to answer the question in a faster way. The highest oxidation number of an element cannot exceed its group number, and the minimum oxidation number of an element is equal to its group number. So in case of the ions that are composed only of one atom, it will take the oxidation number as the charge. That is, it is same as the charge on the ion. And if we consider a complex and polyatomic ions, the algebraic sum of the oxidation number of all atoms in the ion is equal to the charge on the ion. So let us come back. That is electromotive force. So potential difference between two electrodes when no current flows through the circuit. And next important one is standard hydrogen electrode. Standard hydrogen electrode. It is the reference electrode that is being used to calculate the electrode potential of any electrode. As we discussed electrode potential, there we need to calculate the electrode potential for certain thing. Means we have to take the concept that we take some standard value and we start comparing to the existing value. So when we say standard hydrogen electrode, it is nothing but the reference electrode that is being used to calculate the electrode potential of any electrode, and it is used to calculate the electrode potential of various half cell. It is very important to note it is also used to calculate the electrode potential of various half cell. Hence, standard hydrogen reduction potential, it is sometimes even denoted as SHE, and it is a reference electrode whose value or potential is of 0 volts. And then we have electrochemical series. It's very important that you remember not all, but at least few of the order of arrangement of the electrochemical series. It is nothing but the arrangement of element in order of increasing potential, in order of increasing potential. So series has the value from negative to positive, and that is going to tell us how to calculate the standard electrode potential. The electrochemical series, it will tell us how to calculate the standard electrode potential. So it is an important factor that we remember the electrochemical series order, because it's important and it would be helpful in answering the questions. So when we say electrochemical series, so basic arrangement we can say, but if you're going from top to bottom, then we can say that it is, for example, you can take it like if we have F2 PB4 plus Cl2 and so on. So if you are coming in this order, that means we should know that it is considered as a stronger reducing agent. It is considered as a stronger reducing agent, and if you are going in this order, it is considered as a stronger oxidizing agent. It is considered as a stronger oxidizing agent. And the series, why it is being useful, it is going to tell us how to calculate the strength of reducing or oxidizing agent, because based on the order we will be able to predict whether it is a strong reducing agent or it is a strong oxidizing agent. Hence you can lower the value of potential, stronger will be the reducing agent, or vice versa we can calculate. And it is also helpful in calculating the standard electrode potential for cell. The formula as your E star will be equal to EC minus EA. So it helps if the value of E star is positive, when we get, then it is considered that the reaction is feasible. If not positive, then the given reaction is not feasible. Hence, the series helps us to know which metal will evolve hydrogen gas and which will not. So, and all the metals with negative reduction potential, it is considered that it will evolve hydrogen, and wherever we are not getting reduction potential to be negative, it does not evolve hydrogen. So this is all about the concept of reducing agent. If we talk about the weightage of this chapter, it is not too high. That is only around 1% or 2%. Maybe 1 or 2 questions may be asked from this chapter. And the place where you need to focus, is the place of your oxidation number, and if they are giving you a chemical reaction, we should know which is being oxidized and which is being reduced. So based on our concept, let us try taking a test. And here we are having a test of 2 chapters combined. So whichever question would be applicable to redox reaction, I'll try to solve it. And even from electrochemistry, if we feel that it is a simple formula, we can go ahead. Otherwise, We'll do the complete test when we complete the chapter electrochemistry also. So the first question says that we calculate the EMF. Calculate the EMF of the electrode concentration cell they have given. So basically when they give the concentration, like we can say the reaction they have given. If we try to give two reaction for that, that is half cell, left hand side if we say H2G, it will give you 2H plus 2 electrons. And if we say in the right hand side, once again it will be 2H plus 2 electrons, it will give you H2. And they have given us the P1 and P2 value. So for example, if we consider this to be having P1 and this has to be P2, so E naught cell is of course 0. And we know the formula as your E cell will become is equal to E naught minus RT by NF log K. So it's very simple to substitute the values. So here this value is 0, RT by NF, where N is 2 and Faraday's value log of, here K will take up the value of P2 by P1. Since this value is given, we can say RT is, this portion is 0.0591 divided by 2. This whole value takes up 0.059 by 2 log of 0.25 by 2. Hence it will be approximately this value when we calculate, we get it as 0.0178, which we can round it off to 0.018 volt. Let us see if we have, yes of course, 0.018. So let us save that and go to next question. This will come from electrochemistry, so let us skip that. So here we are having what is the cell constant of a cell of an electrode having dimension of 4 centimeter and 3 centimeter. Though this will also come from the same chapter, but it is having, it pulls, or to solve it we need a very simple formula, that is cell constant is equal to L by A. So they have given the value as 2 by 4 into 3, hence it's 1 by 6 centimeter inverse. 1 by 6 centimeter inverse. Let us save that and go to next. The dimension of conductance of a cell are 0.15 pm and 0.95, and the electrodes are again the same cell constant formula. So here also you can apply the same value as cell constant is L by A. They have given the value as 0.05 by 0.15 into 0.95. Hence we could reach as 1 by 2.85. All the values, it's a direct application of the formula because all the values are given to us. Hence it will be very simple to calculate, and answer should be 1 by 2.85. So let us save that and go to next. In the calomel half cell, the reduction is, in calomel half cell reduction is, as we discussed, we said that calomel or SHE we discussed in our, or we have it here. SHE is considered as a half or the potential, or we can say it is a standard reduction potential, or we are taking it as a standard value. In the same way, calomel electrode is also a type of half cell in which the electrode is mercury coated with calomel, that we say it as Hg2Cl2. Just like standard reduction potential, which we are taking as standard hydrogen electrode, we are having a calomel electrode also, and it is a type of half cell in which the electrode is mercury and that is coated with calomel, that is Hg2Cl2, and the electrolyte is a solution of potassium chloride and saturated calomel. So when we say saturated calomel, it should be like Hg2Cl2 plus 2 electrons will give you 2Hg plus Cl minus. This is in the calomel half cell, the overall reaction is considered to be this one. But what they have asked us, here we have. So it is regarding the calomel electrode. Do remember, calomel electrode is also considered as one of the standard electrode. It is taken at some places. Let us save that and go to next. In salt bridge, the electrolyte used should be. In salt bridge, the electrolyte should be. So as I told you, electrolyte is a very important fact. So in salt bridge is a very important factor in your electro. So in salt bridge, electrolyte used should be inert. Salt bridge electrolyte should be inert because salt bridge is helpful in neutralizing the reaction. So salt bridge is nothing but it will be like a U-shaped glass tube which will be jelly-like substance, and that is being mixed with an electrolyte, and you can take it as potassium chloride, KNO3, KCl, KNO3, NH4, NO3, etc. So the electrolytes of the two half cell should be inert, and it should inert in the sense what we should understand. It should not react chemically with each other. It is very important to know it should not react with each other, and because its function is to maintain neutrality. Let us save that and go to next question. During discharging a lead storage battery, which of the following is false? During discharging a lead storage battery. So basically when a lead storage battery is being discharged, it's of course to this answer you should reach by the option. It's 100% sure that density of the electrolytic solution will decrease. CbSO4, it is formed at both electrode, it is known. H2SO4, it will be consumed because that is also known. The only thing is H2O is not being consumed, but it will be liberated. H2O is not being consumed, but it will be in your product side. Like if we say the reaction, how it will be, it is Pb plus PbO2 plus your H2SO4. This gives PbSO4 plus H2O. So when we see, we need to balance the reaction. H2O is being liberated, but in the option they have given H2O is consumed, whereas H2SO4 is consumed, H2O is not consumed. Hence the answer should be H2O is consumed because they have asked false statement, not the true statement. So let us save that and go to next question. The charge required for oxidation of 3/2 mole of SN2 plus to SN4 plus. So we need to calculate the charge, and of course the charge formula is here. Charge required, we can calculate it as N into F. That is charge required, we can say it as N into F. Here they have given us 2 into your For 3 by 2, we need to calculate. F value is known fact 96500. So here it becomes as 3 into 96500. So they have just left it as it is. So we can say the option A should be the right one. Which of the following relation is correct? From the given formula, we all know that formula for delta G naught should be equal to, of course, it should be delta G is minus NFE E naught cell. This is a known formula. So let us save that and go to next. They have asked us E naught of Zn2 plus 2Zn. They have given an E naught of vice versa portion. They have asked it. That is how it is from Zn 2 plus it is converting to Zn, and the other one is we have to give the other vice versa value what would be. So for any electrode, we should remember that one is being reduced and for the other one they are asking for oxidized. So if for any electrode, reduction potential will always be equal to the oxidation potential, but the thing is, hence from the given option we can say that the value, so if we say reduction potential, it should be negative of, value will be same but it becomes negative of that. So reduction potential, you can say that it is equal to minus of the oxidation potential. So the given value, it is minus 0.76. So when we calculate the oxidation potential, it should become 0.76. So in the option, do not say it is only equal to, value alone is equal, but it is negative of each other. Hence, C should be the right answer. The correct cell reaction for given cell, that is Sn to Sn2 plus, it should get converted, and Ag plus should get converted to Ag. So when we say that the reaction, how it should be written, let us write the reaction. Sn, it is getting converted to Sn2 plus 2. So it should have 2 electrons. Okay. Next one, Ag plus, it should get converted to Ag. So of course, it should be electron. So it will give you Ag. So the overall reaction when I need to cancel the number of addition of the electrons. So here we have 2 electrons, and here in the, do remember, this is in the product side and this is in the reactant side. Hence, if I multiply this equation by 2, I shall get it as, this will remain as it is, Sn, it gives you Sn plus 2 electrons, and this reaction will become as Ag plus 2 electrons will give us 2 Ag. And here also it should be 2 because we have multiplied the whole equation with 2. So now this will get cancelled and club the reactant and the product. Hence, of course, your reaction will become as Sn 2Ag plus gives us Sn2, that is your plus 2 plus 2 Ag. In the option, we have to check whether the given reaction matches. So it should be Sn 2Ag plus Sn plus 2 2Ag. Hence our option D should be the right one. Let us save that and go to next. Again, same format, that they are asking us to calculate the E naught cell value and your delta G using formula. So they have given us these two values and we have to find out the delta G naught. So we all know the formula for delta G is delta G naught is equal to minus NF continue. Yeah. So we were discussing with E naught Zn value given, and we have to calculate the delta G naught. So we know the formula of delta G naught as minus NFE, and here we have to calculate the E naught cell value from the given one. So when we say delta G as the values they have given us, easily we can add up 0.76 with 0.34, it will be equal to 1.1 volt. And if we substitute in the above formula, delta G is equal to minus N, which is equal to 2,96500, and this value we have calculated, so it is 1.1 joule. Thus, we can say the value as 212.3 kilojoule. Let's check out if it is there in the option. Yes, it is 212.3 kilojoule. Hence, let us mark that and go to next. For E naught, A3 plus by A plus is X volt. For E naught, A3 plus by, they have given us three different value, that is E naught of this equation, E naught of A3 plus. Just notice here it is A plus and this is A plus 2, and we have to calculate for A plus 2 by A plus. So when we try to solve this, here we are given the values, hence it is just a rearrangement of each value and you will be able to reach to the answer. That is A3 plus 2 electrons, it's of course it will give us A plus, and here E naught value we can take it to be X. Let us assume that this is delta G1, and this is A plus 3 plus electrons will give you A plus 2 E naught, that is equal to Y, and this is delta G2. This is all assumption, and A plus 2 plus again 1 electrons will give us A plus, and let us assume this is what we need to calculate, hence we will take it as delta G3. So if we want to calculate as delta G3, it is equal to delta G1 minus delta G2. So what is the value it is given? As it is given in formula of delta G3, we can say it as NFE naught. Hence, for this, it is 2 into minus, of course, F X minus 1 F Y. So, if we want to calculate as E naught of A plus 2 to A plus, we will get it as 2X minus your Y. It is 1. So, 2X minus Y. So, when we say it as minus NFE, this will be of minus value, hence this will become plus. So we are getting it as negative of that. So you will get the answer as 2x minus y to be dissociation. Hence it is just a rearrangement how we reach to this portion. All the values they have given and we have to rearrange and arrive at this value. Let us save that and go to next. This question we will deal it in the next chapter. Hence let us end the test. So there are few questions which we have not attempted since it belongs to a different chapter, and the questions which are in green, that will help you to find out that the answer is right. And with question number 5, maybe, okay, we have not attempted this because it is from electrochemistry, but red color indicates that the answer marked is wrong and green color indicates that the answer we have got is right, and yellow or orange it will tell us that we have not attempted the question. And if you click on the question, it will give you the right answer as well as the explanation for that particular answer. So it will be very easy to find out the answer if we are gone wrong, and we can take the same test n number of times unless and until all the questions are Correct. That's all for today's class, student. If you have any doubts, you can reach out to us with the help of ask feature in this application, or you can reach out to us with the Telegram chat application, or if you have any doubts in any particular chapter, you can reach out to Play 6 management for one-to-one tutoring from the Play 6 tutors. Thank you.